Imagine you're standing in ancient Rome. There's no crane, no forklift, no diesel engine, no steel cables, no construction elevator, and yet there's a gigantic block of stone hanging 50 feet above your head, and somehow you're supposed to put it on a building. Now imagine the block weighs several tons, and the only thing holding it up is a wooden machine powered by men walking inside a giant wheel. Yeah, welcome to Roman construction, because the Romans didn't just build giant buildings, they built machines to build giant buildings. And some of those machines were so clever that, even today, they make you wonder how people figured them out in the first place. But there was one enemy every Roman engineer had to fight: gravity. And gravity didn't care how powerful Rome was. So let's go to the moment when Rome decided to build something completely ridiculous. Around 72 AD, Emperor Vespasian ordered the construction of what would become the Colosseum. And this wasn't going to be some little arena. This thing was going to hold tens of thousands of people. It would rise roughly 50 meters into the air. It would contain enormous stone blocks, concrete vaults, arches, stairs, corridors, and an entire mechanical system underneath the arena. There was just one tiny problem. Rome had to actually get all that stuff up there. And this is where the Roman crane enters the story. Now, when you hear the word crane, you're probably imagining a giant steel tower sitting next to a skyscraper. The Roman version was a little different. It was mostly wood. It used ropes. It used pulleys. And it used something that modern construction companies generally don't put on the payroll anymore: humans. Inside the crane was a giant wooden wheel. Men climbed inside it and walked. Their weight turned the wheel. The wheel turned an axle. The axle pulled a rope. The rope ran through pulleys. And the stone began to rise. Think about how absurd this looks. A group of exhausted Romans are literally walking inside a wooden hamster wheel, while a several-ton block slowly floats upward above them. And if everything works perfectly, beautiful. But if one part fails, you got several tons of Roman architecture becoming a very fast-moving problem. Because lifting a giant stone isn't just about making it go up. You have to control it. You have to keep the rope under tension. You have to keep the crane balanced. You have to coordinate the workers. And you have to make sure the stone doesn't swing into the building you're trying to construct. So imagine the construction site. Workers are shouting. The wooden wheel is turning. The ropes are tightening. The crane is creaking. A giant block is hanging over everyone's heads. And somewhere nearby, Brass is watching. Our little forge jackal has one job: figure out how this machine works. Unfortunately, he has another job too: not getting crushed by it. Because the Romans had discovered something incredibly powerful. You don't need a giant engine if you can multiply the force you're already producing. That's what pulleys did. One rope pull could become a much more powerful lifting system when combined with multiple pulley wheels. And suddenly, a machine made from wood and rope could move weights that would be completely impossible for one person to lift. But Rome wasn't finished, because the Colosseum wasn't made from one type of material. The Romans were combining enormous quantities of stone, brick, concrete, timber, and metal into one gigantic structure. And that meant the machines couldn't stop. Stone had to arrive. It had to be moved. It had to be lifted. It had to be positioned. And then another piece had to go on top of it. Again, and again, and again. The building was basically a giant assembly line. Except the forklift was a man walking inside a wheel. And then things get even crazier. Because once the Colosseum was finished, the Romans didn't just leave the machines outside. They put machines underneath the building. Under the arena was a hidden mechanical world. There were corridors, trapdoors, hoists, platforms, and numerous lifting mechanisms. The ancient sources and archaeological evidence show that the arena's underground system used windlasses and elevators to move equipment, animals, scenery, and other loads upward, which means the Colosseum wasn't simply a giant stone bowl. It was a machine where the audience could sit above, while an entire industrial operation was happening underneath their feet. And here's where Roman engineering gets even stranger. Because the Romans weren't only fighting gravity with cranes, they were fighting it with arches. They were fighting it with vaults. And eventually, they were fighting it with concrete. Take the Pantheon. Its enormous dome spans roughly 43 meters. That's an incredible amount of material hanging over a huge empty space. And Roman engineers understood something very important. If you make the entire structure equally heavy, gravity is going to have a very strong opinion about that. So the Romans made the dome lighter as it rose. Heavier materials were used lower down, lighter materials were used higher up. And those famous recessed squares in the inside of the dome, the coffers, they aren't just there because somebody thought they looked nice. They also reduce weight. The Romans were essentially negotiating with gravity. Fine, you can pull everything downward, but we're going to make sure there's less stuff for you to pull. And this is the part that makes Roman construction so impressive. There wasn't one secret Roman super machine. There wasn't some ancient engine hidden under the Colosseum. It was a combination of simple machines: levers, pulleys, winches, wheels, ropes, cranes, and an enormous amount of human coordination. The Romans took technologies that were individually simple and combined them at a ridiculous scale. A pulley doesn't look impressive. A wooden wheel doesn't look impressive. A rope doesn't look impressive. But put hundreds of them together, add thousands of workers, and give them a project the size of the Colosseum, and suddenly you've created one of the greatest construction operations of the ancient world. And there was something else making all of this possible: organization. Because a machine is useless if nobody knows what to do with it. Workers had to quarry stone. Other workers had to transport it. Others operated cranes. Others prepared concrete. Others positioned blocks. Others built arches. Others managed the materials. It wasn't just construction. It was logistics on an enormous scale. And that's the part we don't see when we look at the ruins today. We see the Colosseum. We see stone arches. We see broken walls. We see a monument. But imagine it when it was being built. The sound of wooden wheels turning, ropes tightening, hammers striking stone, carts rolling across the ground, workers shouting instructions, cranes swinging enormous blocks through the air, dust covering everything, and thousands of people moving around one enormous machine. The construction site itself. Rome didn't have the technology to simply overpower gravity, so it did something much smarter. It learned how to work with it, one pulley at a time, one rope at a time, one wheel at a time, one enormous stone at a time. And that's why the strangest thing about Rome's giant buildings isn't that they're still standing, it's that they were ever built in the first place. Because when you look at the Colosseum today, you see an ancient ruin. But 2,000 years ago, the Romans saw something completely different. They saw thousands of tons of stone hanging in the air, held up by ropes, moved by wooden wheels, operated by human beings, all while an entire civilization waited for the next piece to go into place. Brass looks up at the Colosseum, then he looks at the enormous crane beside him. Then he looks back at you. And after watching several tons of stone being lifted by men walking inside a wooden wheel, he has reached one final conclusion. The Romans didn't invent the forklift, they just decided they didn't need one. And somehow, they were right.